Hi, this is Alex from devstories.eu. AlphaFold, Protein Structure Prediction, Episode 15 of 21. Your protein model is surprisingly small, sitting under 100 million parameters. You successfully predict the structure of a 500 residue sequence on a standard 16GB GPU. But when you input a 1500 residue sequence, the process instantly crashes with an out-of-memory error, suddenly demanding over 80 gigabytes of VRAM. This catastrophic scaling happens because of a specific architectural trait called the memory bottleneck, O of n cubed attention. According to the FastFold paper by Cheng et al., this explosive memory consumption has nothing to do with the model weights. The entire AlphaFold model holds only 93 million parameters. The bottleneck lies entirely in the intermediate activations generated during the forward pass. As the sequence length grows, the memory required to store these intermediate tensors scales cubically. To understand why, we have to look inside the Evoformer. The Evoformer is the main structural trunk of AlphaFold, consisting of 48 stacked blocks. Inside each block, the model relies on a specialized attention mechanism. Standard transformers, like the ones used in language models, typically have attention mechanisms where memory scales quadratically with the sequence length. They only compare a one-dimensional sequence against itself. AlphaFold is different. It uses a two-dimensional intermediate representation to model pairwise interactions between amino acids. Here is the key insight. To accurately predict three-dimensional protein structures, the network cannot just look at pairs of residues in isolation. It must evaluate triangular relationships to ensure the predicted distances between 3 points are physically possible in three-dimensional space. To calculate this, the attention module generates intermediate activation tensors. The memory footprint of these tensors follows a strict formula. It is the sequence length cubed multiplied by the number of attention heads, multiplied by the byte size of the data type. AlphaFold uses bfloat16 precision, which takes 2 bytes per value. Let us trace the math for the developer who crashed their GPU. When you pass a 500 residue sequence into the model, the sequence length is 500. The cube of 500 is 125 million. If you have 4 attention heads, you multiply 125 million by 4 and then by 2 bytes for the precision. A single attention layer creates about 1 gigabyte of intermediate activations. Your 16 gigabyte GPU handles this with room to spare. Now you change the input to a 1500 residue sequence. You only tripled the input length. But because the scaling is cubic, you must cube 1500, which yields over 3.3 billion. Multiply that by 4 heads and 2 bytes, and that exact same single attention layer now demands almost 27 gigabytes of memory just to store its activations. Because the network passes this data through 48 consecutive Evoformer blocks, the total memory requirement instantly exceeds 80 gigabytes. The tensors swell so rapidly that the hardware simply aborts the process. This is why AlphaFold requires heavy optimization for longer sequences. The raw parameter count of a neural network tells you almost nothing about its hardware requirements when the internal geometry forces intermediate data to grow in 3 dimensions simultaneously. If you want to support the show, you can search for Dev Stories on Patreon. That's all for this one. Thanks for listening and keep building.